Continuing on, looking at problem solving, again, different ways that we can come up with good answers. So when we look at this concept of creativity, creativity is the ability to generate original ideas and maybe look at things in new ways, for example. So if we're looking at kind of the difference between divergent and convergent thinking, right? Convergent thinking basically is looking at kind of your basic knowledge of something, your previously learned responses to things, whereas divergent thinking is the ability to generate unusual yet appropriate results, right? So we're able to maybe do something in a slightly obscure way or different way, and yet we're still able to kind of resolve that, and that's the concept of creativity. We're divergently looking at a problem, and we're coming up with slightly new perspective. So getting better at thinking, we redefine our problems, we use sub-goals, we adopt a critical perspective, we consider the opposite, thinking divergently, and experimenting with various solutions. Sometimes it's okay, even if we get the right answer, to try different answers. Sometimes what we'll find is that we'll get the answer right and we'll just give up. But what if instead we tried a different response? We might find that sometimes we'll still get the right answer, but we'll be going about it in a different way, and we'll realize, wait a second, maybe this wasn't as simple or wasn't as basic as I once thought. Next part here is looking at language. So language acquisition is a really fascinating topic, and so for some, they actually look at language as kind of a very unique kind of human characteristic. There have actually been quite a few debates looking at this idea: can animals, for example, use language? And some psychologists say no, and some say yes, and really the debate is over the idea of communicating original thought. Where an animal might be able to be taught to communicate something like they want a certain food item, or they want that maybe they can prove that they can kind of tap their foot so many times, or do certain types of behaviors. What we'll find is that those seem to be limited to mimicking, whereas language almost has this capability of speaking out or generating original content. And so while what we might see kind of maybe dogs communicating with other dogs, or by barking, or maybe we'll see bees kind of communicating idea of where different flowers are, for example. They're not necessarily they can't communicate like they had a dream of flying into a spaceship and falling out into a cloud and all this stuff. They don't have that ability to communicate things as specific as that, and so some would say that they don't. There have been some studies of certain chimpanzees when they learn sign language, where they initially will have the ability to mimic certain signs, can sometimes start to maybe use signs what they initially thought were incorrectly, but what they were realizing was they were trying to morph different signs together to create a new word. And so some have said, well, maybe there is a possibility of animals using language. The basic smallest units of language is phonology. So that's where we break words down to their smallest unit. So for example, the word cat, right, has 3 phonemes. So k, a, and t. Right, so C-A-T. And if we said like the word bat, again, 3 phonemes, B-A-T, B-A-T. Now, if I, for example, use the word chat, right, which is C-H-A-T, we would find that chat still has 3 phonemes. So phonemes isn't necessarily dictated by how many letters, but how many sounds are being made. Now, once you put enough phonemes together, right, in order to make a meaningful word, that's called a morpheme, right? And morphemes, right, when strung together in sentences and everything else, we find that we start creating much more complicated language. Now, most of us, you will use something like syntax, as we create certain phrases. We know how these words to go together, those words to go together, and semantics, right, which creates a lot more meaning for us in our language. Now, what's fascinating is the language is almost kind of a prepared learning area for humans. Humans are almost have an ability to pick up and use language at a very incredible rate, and with little to no formal education. In fact, what we see is that without any formal education, you can pick up and use language very accurately. And so it's fascinating. You can ask a child, "Hey, do you know that the sentence you just used has a noun and a subject and a verb and a how'd you know not to put the preposition at the end of a sentence?" And they can't tell you how they know the rules. They just know the rules. And that goes back to that idea of procedural memory. Sometimes we know how to do something without necessarily knowing how we did it. And so some have actually theorized that, well, is this like an inherited thing? Like, is language something that we just are all pre-programmed, and no matter what, we're just going to be able to use language? Well, that's actually not the case. We find that language it has this capacity. We have the capacity to learn, almost like a prepared learning. But if we don't actually have an engagement in the use of language within a critical window of time, then we will actually have this almost inability to pick up and learn language in the same way afterward. So, in fact, if we looked at cases like the child called It, and those kind of cases, we'll find that when we're raised outside of an environment where language either is not used, or in the cases like the child Clit, where the parents refuse to talk to the child and engage with the child, and those things, that the child kind of missed the window of learning. So even when the child was pulled out of that situation and taught how to use language later, that child actually had a lesser ability to pick up on language. It took a lot longer, and in fact, even most of the language growth was somewhat stalled or halted. Right, so a lot of telegraphic speech, like "I go," "we eat," as opposed to being able to use much more kind of deep language skills. We also see when learning language, initially we will overgeneralize certain types of words or phrases until we can find where those words and phrases work best. Some say that there's almost kind of a universal mind and a universal grammar, and we all tap into that nativistic approach. This idea of there's always, in every culture there's a Father Time and Mother Earth and those kind of concepts. Where others, again, just kind of look at this idea of having this predisposition to learn language, just a prepared learning kind of concept. So finally, we're looking at the concept of intelligence. So capacity to understand the world, think rationally, use a resource effectively when faced with challenges. Now, oftentimes we look at the term intelligence, we think that person's very book smart, or we think that person is very, they're really good at math or something like that. But what we find is that intelligence is less just about kind of the ability to perform academically. While that can be a good indicator, it often, again, is looking at this ability to think rationally and use our resources to accomplish what we need and overcome challenges, right? So that's really kind of a little bit more about it. And so you hear people who've never gone to a formal business school or even finished their high school education and find ways they can be very successful in business, or ways that someone can, survive in the wilderness and those things, without, any kind of formal education. So it's just really fascinating to look at the different kinds of intelligences. And so initially we thought of intelligence as a singular concept, right? You either have this kind of G-factor intelligence or you don't. But what we found is that really intelligence has multifaceted. In fact, Gardner looks at the idea of intelligence on 8 different kind of pieces here, or 8 different forms, right? And so, we have our musical intelligence here, we have our bodily kinesthetic intelligence. So what this means is like athletes seem to have an increased ability to kind of know where their body is at in space, and they're able to do things that most of us really can't do, without that certain types of understanding and intelligence in our mind. Our mathematical intelligence, or linguistic, or writers, or readers, those kind of folks there. All right, we have our spatial intelligence, people who are very kind of almost, accurately can determine direction from wherever they're placed. And what we see here is we have these 2 kinds here, interpersonal and intrapersonal. And this is about our ability to interact with other people and our ability to understand our own emotions. And if we talk about something like autism spectrum disorder, what we find is that oftentimes they will struggle with the interactions with other people. And so they will struggle to understand the kind of interactions and this interpersonal connection of, if someone else is sad, they don't feel sad, and they have trouble understanding that, or even kind of understanding that ping and pong of conversation. And then you have your naturalistic intelligence, again, that survival, that ability to kind of adapt quickly in your environment. And then finally here, I want to mention is this idea of fluid versus crystallized intelligence. Fluid intelligence, kind of processing in the moment, reasoning, things through, doing that kind of mathematical kind of pieces, whereas crystallized intelligence is more about what we've accumulated, what we've kind of already learned, what facts, what's, information we can recall and use to solve that problem. And so again, 2 different kinds of intelligence, fluid versus crystallized. And so finally, how do we measure intelligence? So, intelligence is measured, really, I guess if we're going to step back, why do we measure intelligence? Well, a big part of it is just, specifically looking at like early kind of school systems, looking at the difference in performance in different children and trying to understand why one child might be academically successful and maybe another one seems to struggle. And so they were really looking to see where the strengths were and where the areas of improvement can be found, or the areas that the child may have a need. And so creating these intelligence tests, again, wasn't necessarily for the purpose of saying, oh, you're smart and you're dumb, but more in the sense of saying, you are very good in these categories, in these areas, and struggle with these other ones, and how can we help? And so it's using a very kind of interesting method of kind of identifying several different categories of what most people determine as intelligence, creating tests, several tests for each category, and then giving the test to a large group of people, right? Over time, we find an average for that group. We call that a normative population, right? So if we gave it to children between the ages of 5 and 15, and we gave 100 tests to 5-year-olds, 100 tests to 6-year-olds, 100 tests to 7-year-olds. Again, just kind of creating a average kind of responses based on that person's age, right? Based on kind of their ability to accurately answer these questions. And so the way we determine someone's intelligence, and especially in the old IQ tests, is we would take their chronological age, their actual age, and their mental age, right, which is the score they got, how well they performed, and we would take our mental age divided by our chronological age, and we multiply that by 100, and that would give us that person's score. All right, and so if, for example, you're 8 and you scored about average with other 8-year-olds, then you would score 100, right? That would be right there in the middle, right? 1 over 1 is 1 times 100 is 100. But for example, you'll say you were, you're 6 and you scored as well as a 12-year-old, then that's 6, then that would put you at something like 2 times 100, which is 200, right? That would be a really high score, almost impossible, right? And anyways, and so you can kind of look at, how do these systems fall. And so here you can see most people you would expect would fall here within this kind of range. At least 68% of the population is going to fall right here in this kind of normative average. Now you'll notice that it kind of spans out a little bit, and so we see that most people fall between 85 and 115. So this is what we call a standard deviation. 15 points away from the norm, from the 100, is average, right? And then once you're over 15 points, once you're 30 points away from the average, right, that is where that would make you 2 standard deviations away. So 1 standard deviation is 115, 2 standard deviations would be above 130. Then you'd say that person's statistically significantly different than the rest of the population, because look, it's only 2% falling out here. And so if someone falls really up here, that person, we would call that person a savant or a genius, or a really high level. Whereas over here, right, you'll see that if someone falls below that was where we began the definition of mental retardation, or what we used to call mental retardation, now we call intellectual deficiencies and developmental delays. But again, that person's statistically significantly different than the rest of the population in that area. Now, I do want to differentiate a intelligence test from an achievement test. An achievement test is what you have in our classes, right? I determine if you've achieved a level of understanding of concepts that we've learned, right? That's achievement, right? Whereas a kind of intelligence test is more about your capacity to learn, your capacity to understand and work in an environment. Kind of a little bit different than an aptitude test, but probably more similar than an achievement test. An aptitude test is going to predict your ability to perform in a particular area or line of work, where it's like, follow this, this chart to figure out how to solve this problem, and your ability to follow that chart and do that shows your aptitude to learn. Now, we have 3 different types of ways that we evaluate an assessment like an intelligence test. One is reliability, right? Intelligence, we know, shouldn't be shifting minute by minute or even day by day or even week by week. It should be something that's somewhat stable. And so I would expect that if a child took an intelligence today and then took a different intelligence test in a week, we should see somewhat similar results. That's called reliability. And so one of the ways we test it is test, retest reliability, right? We test it and test it again, or split half. We take half the questions and give it to the person, and then we have them take the other half of the questions, and then we compare. We should see similar results in comparing the two. Validity, very common method of assessing a test. Validity is just saying, is it measuring what it actually purports to be measuring? And so you can have, that's called content validity, and then you can also have predictive validity. Can it somewhat accurately, taking the information we have, predict what the person is able to do or not do? And finally, we have our normative standards, right? And so again, we're comparing. We don't want to try to compare maybe a 6-year-old's kind of performance to a 30-year-old's performance, right? In other words, so when we create a test, we norm it to that population, to that child's age, or to that person's kind of socio-cultural ethnicity, and all those things. All those factors do have a role. So for example, when they first created the intelligence tested, a lot of it was middle-class white children at a very particular age range. And so what we find is now we're trying to give the same test and assessment to African American or Hispanic or other forms of other populations, and now they're not performing to the way that we would expect them to, and sometimes quite a bit less because of the way the questions are asked or cultural phrasing, and that really became a problem. And so we have to be careful of our normative standard, making sure these normative standards are based on the person that we're giving it to. So earlier I kind of mentioned kind of the base level of mental retardation, kind of beginning at that 70, or again, one below that would be 69, right? So And then so that would be a mild mental retardation, whereas as we go up the scale, 54 being the next standard deviation away. Again, 15 points difference, right? And then again, 29, 39, and then down to 25. Things that can cause that, again, Down syndrome, familial retardation, or fetal alcohol syndrome. And someone above 130 is considered gifted. We have to be careful as well when we give these assessments that we have to understand that not only does background and culture make a big difference, but as well, anytime we give a test, the test is a test on a day. We have to make sure that we follow it up with other measures and other means to determine that child's capability and everything else. And so that's why we have lots of different assessments and lots of different ways to get to the same information. Thanks for listening. We'll talk to you guys later.